Hello and welcome. My name is Nicola O'Byrne and I am the Marketing Manager with the Connected Motion and Robotics team in the Industrial Automation Group in Analog Devices. I have been with Analog Devices for over 20 years, working on precision analog to digital converters for much of that time, and for several years also working specifically on industrial automation and more specifically motion control and robotics. The world around us has changed significantly over the last decade, with global trends driving an increase in the uptake of automation and robotics. Many headlines in the media have focused on the potential negative outcomes of automation and robotics, reflecting fears that robots specifically may take people's jobs. The world has changed almost unrecognizably so also over the last 6 months in the current global pandemic. Today I will talk to you about Analog Devices' more optimistic outlook on industrial automation and how we continue after almost 55 years to take on the toughest challenges that really make a difference. There are many new trends in the world of robotics. The landscape of manufacturing is changing. Globalization and its associated wealth gains have driven a shift in consumer behavior, where mass customization is expected, much shorter lead times are expected, and manufacturers have to figure out how to respond to this. Some of the ways they're responding is by increasing flexibility in their production lines and being able to cope with different batch sizes. They are also thinking about reshoring their manufacturing facilities or bringing those facilities closer to the area of consumption. Manufacturers are also faced with challenges in the form of finding skilled labour. There are skilled labour shortages, there are ageing populations and workforces, and they're also dealing with high employee turnover. So these increasing consumer demands are driving a shift towards a high mix, low volume type environment, away from the more traditional low mix, high volume production environment that we're used to seeing. And this type of dealing with these different batch sizes basically requires flexibility, as I said, in the workplace. And by flexibility, we mean being able to change from making one type of product to another type of product quite quickly. The return on investment for automation is also increasing as robots become more affordable and as they also realize quicker returns in terms of productivity and flexibility. Traditional industrial robots, these are the kind of robots that you might be used to seeing in a factory setting, making cars maybe, or making electronic assemblies. You see these types of robots can be quite large, able to lift a full car, for example. So they're very strong, they move very quickly at high speed, and therefore they're very dangerous. So traditional industrial robots are generally kept inside safety cages, or they can also be kept inside what we'd call a virtual safety curtain or a light curtain, for example, implemented with sensors. So these types of robots don't have any humans around because they're too dangerous. Nevertheless, these robots are still pushing increases and advancements in the areas of precision motion control, multi-axis synchronization, power and size efficiencies, for example. So there are some of the trends in the traditional robots. Then we also have collaborative robots. These are also often called cobots for short. Collaborative robots work alongside humans and in the human workspace. They are very easy to install. Their cost price has come down significantly over the last 5 years or so. So they are easier to use and they're more affordable. And this is leading to an increased uptake of this kind of automation in small to medium enterprises or SMEs. Basically, the fact that they can be installed quite easily is reducing the total cost of ownership for SMEs, where once you had to have a specialized engineer from the robot making company, the robot OEM, a specialized engineer would have to come on site and physically install and commission that robot to do a very specific task. And this could take a number of days or even a week in the case of a traditional industrial robot. But with a collaborative robot, the factory owner or the robot user can actually install that robot quite quickly. And the programming of that is very easy because they use like a teaching pendant or a HMI type interface. So you don't need heavy duty coding in order to implement and use this robot. So as I said, this is leading to an uptake in the use of robots in small to medium enterprises. And like I said, it reduces the total cost of ownership if the SME couldn't afford that robot or automation in the past. Something else that increases the uptake of robots is new business models. Things like rental of robots are business models that we're seeing emerge, and this makes them even more affordable. So overall, what we're seeing is an effective democratization of automation. Companies can get their hands on automation that they couldn't get before. Now, technology is also enabling the adoption of robots. Technology is allowing robots to operate in new applications and new use cases, places they couldn't operate in the past. Because of this is leading to very high growth in this space. But with this growth and this success comes challenges. And these challenges are both in the form of technical challenges and social challenges. Collaboration and technology, it's shifting the limits of automation essentially. As I said, automation is appearing now in new environments, new types of use cases that we haven't seen before. These environments where there are humans, this is increasing a focus on human safety, of course. And this increased focus on safety requires heightened sensing, more technology for sensing. And this is a challenge. Digitalization is another challenge. Industry 4.0 is all about connecting the real-life factory to the digital world. But how do you do that? How does the factory owner do this? Machine health monitoring provides an opportunity to provide productivity gains by extracting information from legacy equipment, new equipment, or robots. But how do you make the right measurements? How do you turn these measurements into actionable insights and extract useful data? And how do you combine this with machine learning and extract value from big data? Simplification is another challenge for robot makers. Simplification can be in the form of ease of use, such as the installation of the robot that I mentioned earlier, and also flexibility in terms of quick tool changes. So plug and play interfaces are critical on grippers and end effectors so that the user can quickly change a tool with no special programming required or no special workmanship required. They can just quickly snap on and snap off those tools. So seamless plug and play interfaces that the robot maker must enable and provide. These are key to simplification. Now, simplification is very important because this enables the adoption of robots for small to medium enterprises, as I described earlier, because they can program these and deploy them quite quickly and get a quick payback on them. But simplification is also very important to large global organizations. As I mentioned earlier, there is probably going to be a shift towards moving manufacturing facilities onshore. So the idea of this large, mega fixed factory in one place, that's probably going to become less and less common, and we will see more modular factories appearing. So smaller factories closer to the source of consumption. And simplification feeds in here because if you think about a global dispersal of your operations and your facilities, then standardization and simplification in the form of standardization and consistency will be key to that. Now, thinking about the workforce, there are real fears out there about robots and automation taking jobs. But the reality is not as stark as the headlines make out. Manufacturers have to do more with less. And the reality is that it's tasks that are going to be automated more so than entire jobs. You may have heard of the 3 Ds. This is the dull, the dirty, the dangerous. These are the type of tasks, these unergonomic tasks that are going to be automated by robots. And really, it's only a portion of people's jobs that will be automated like this rather than the entire job and the unergonomic portion. And this will free up humans to do more rewarding, more higher cognitive, more engaging jobs if they're freed up from these dull, dirty, or dangerous tasks. This will lead to a more engaged employee, a happier workforce, but it will also reduce injury, things like repetitive strain or back injuries. It will also then lead to less downtime from employees in terms of sick pay. It will lead to less turnover of staff or attrition. So really the idea is that jobs are going to be reshaped or augmented rather than being diminished or being replaced. Digitalization, artificial intelligence, and automation in general, these are going to take on the dull, the menial, the repetitive and boring tasks. These are tasks that humans don't really want anyway, and this will lead to a more engaged workforce. Now, there is also there's good news. There are still lots of jobs out there that can't be automated. So jobs that involve human skills, things like empathy, critical decision making, things like process knowledge or craftsmanship. Tech is not going to compete or replace with long-standing experience of how a process runs or a particular craftsmanship. The vision really is for a transformation to a skilled workforce, and a skilled workforce that is assisted by intelligent robots, essentially. So humans are going to continue to be in the loop. And this increased automation will lead to more competitiveness on the part of the business. And this will drive more jobs. And these jobs will be, as I said, of a more rewarding, engaging nature. They're likely to be higher paid jobs. And it will lead to more or an increased number of jobs being available, such as hardware development, software development around robots and automation, programmers. And like I said earlier, this isn't deep programming, this is more accessible programming. And in fact, a lot of robot companies are offering free training to users of robots to become effective robot programmers, if you like, to enable the adoption of that automation. Mechatronics, services. So like I said, more competitiveness will lead to more success for a business and therefore more jobs overall. And having mentioned services, actually robotics as a service is another area. And it has been shown, and I think it's widely understood, that the growth rate of service-based businesses tends to be much higher than manufacturing businesses. So there's likely to be more jobs and more success in that space also. However, retraining is critical to all of this. Retraining is needed to sustain this growth. It's also critical to allow the workforce, these people who are a threat of being displaced or feel they're going to be displaced. Retraining is needed to allow them to capitalize on these new jobs. If they cannot fulfill their role by turning to the more skilled portion as the less skilled portion is automated, if they find themselves completely displaced, then retraining is critical to these people. And estimates have shown that 96% of the workforce that feel they're a threat from technology can find similar to better work with retraining. And as I said earlier, process knowledge or craftsmanship, these are the types of things that can't be automated and that tech won't replace. But in actual fact, you can add digital skills to that type of worker. And it's easier to add digital skills to somebody with process knowledge than it is to do vice versa. So if you have somebody who's a digital or an IT expert, it would take a long time to train them and get them the level of experience on process knowledge or craftsmanship. Now, if you're employing somebody completely new or somebody very young, you still need to train that person. And it turns out that technology and automation can actually also provide great advantages to the whole training experience. If you take artificial intelligence and augmented reality, these are terms actually that can incite a lot of emotional responses and anxiety in people. But artificial intelligence can be something very basic, something as simple as, Siri on the phone, or, telling the phone in your car to dial your friend. That's artificial intelligence. It doesn't have to be big and scary. But artificial intelligence and augmented reality, these have a role to play in the re-education and reskilling of the workforce. And what I mean by that is employees can be immersed in the situation using augmented reality, and they can also be physically using the equipment at hand or the workstation, and augmented reality can guide them through that. And then artificial intelligence can actually gather data while the person is interacting with the machine or the robot, and it can monitor that, log that data, and it can be analysed afterwards to the overall experience. So it can be fed back and improve the training experience for the next person. So retraining is critical, as I say, but what is also critical is the pace of retraining and reskilling. And I believe that the pace of reskilling is not at the same rate as that of the rate of adoption of automation. So the pace needs to quicken. As I said before, some robot companies are doing what they can to help people learn how to program robots or how to use that automation. But I think that governments also need to do their part in this. So some kind of public-private partnerships really are needed, and investment is needed here in order to capitalise on the opportunities of automation. And really discussions around this kind of investment would be far more useful than topics like taxing robots, which is just completely counterproductive. And this was the outlook even before the current COVID-19 pandemic. But now that we're in the grip of this pandemic, investment in reskilling is even more important, because robots and automation are going to aid in the recovery, as I will speak to shortly. So it's vital that people get on board now, and that governments get on board with reskilling and retraining. Lastly, organisational changes are probably going to come also. We're seeing some companies set up a CRO, or a Chief Robotics Officer position and department, in order to oversee the deployment of automation and robots in their businesses. So I have spoken at length here about industrial robotics and robotics in the manufacturing place, and by now one can appreciate that automation and robotics can ensure a safer, healthier, more rewarding environment. But robotics is not limited to the world of manufacturing. There are many other industries that also make use of robotics. Industries like hospitals, hotels, retail, logistics centres, for example. And prior to the COVID-19 pandemic, there was a consistent rate of adoption of robotics. There was a high growth rate in collaborative robots and service robots or mobile robots. These would be the type of robots used in these kind of environments, like hospitals or labs or hotels or, logistics centres. So there was a very healthy rate of adoption, but the pandemic now is seeing an acceleration of that adoption. And the reason for this is that people and business owners, they want to diminish human contact. They want to reduce that. They also want to, or they need to, supplement the missing workforce. People who are either missing because they're ill, or because they have to go into quarantine, because their government has instituted a lockdown. So these types of establishments or facilities have to do more with less. And they have to do even more in the face of a greater demand. If you take a hospital, there's more demands on them right now. Laboratories have higher demands. Logistics centres, like distribution centres, they have higher demands, as e-commerce has had an explosive growth as people turn more to online shopping and away from going out into the stores. So I'll take you through a few examples of how robots are helping in this situation with COVID-19. But as I do that, you might begin to see that people might turn away from fearing from robots and actually start to welcome them and think that they may almost come to the rescue, because I believe that robots can be an aid to economic recovery. they can help to sustain a business during this period while there is a missing workforce. They can also help to sustain a business through the next phase of this. We don't know how long this will be, but the phase where we come back to work, but we have new norms. We have social distancing in the workplace. And robots can help manufacturers and other facilities like hospitals or wherever else to implement the safety protocols that will be demanded. So robots will not just save jobs, they'll save entire businesses as well. They also will be there to protect humans from, as I said earlier, hazardous tasks that can cause injuries, but also hazardous environments if people are afraid of contracting COVID-19. So I think that actually the robots are coming to the rescue. I want to take you through 5 examples where I think robots are helping in the fight against COVID-19. The first is pivoting manufacturing lines. You've seen probably in the media how some companies are turning to make critical equipment like ventilators or face masks. And robots can help in this, and automation in general, through its flexibility, through this quick tool change and quick redeployment of automation. It helps companies to pivot very quickly from making one type of item to another where possible. It also will have the knock-on impact of reducing that distance between supply and demand that I spoke about earlier, or reshoring the facilities and manufacturing. And this will reduce a dependency on the global supply chain. Another area that I mentioned already is worker separation and worker distancing. And this one is pretty obvious. If you take on robots, you can install a robot maybe between every second employee, for example, and that will provide the worker separation that is needed. Even in facilities, like I've seen examples of recycling companies, for example, can even use robots because artificial intelligence enables robots to be able to distinguish between different items. So picking and sorting through recycling materials is something that a collaborative robot can do, and it's somewhere where you would have quite close proximity between the workers on that line. Another area or another example is cleaning and disinfection robots. And this is an area of very high growth at the moment in the COVID-19 pandemic. There are 2 main types of cleaning robot. These are mobile robots, like autonomous guided vehicles or autonomous mobile robots. And some have sprays that are fitted to them where they physically spray out the chemicals for a deep clean. And some use ultraviolet light or radiation. The chemical spraying robots are good, but there are areas and equipment, if you take a hospital, for example, that may not be suited to having chemicals sprayed in that particular environment. Or, for example, a CAT scanner. If you look at a CAT scanner, a CAT scan takes a couple of minutes for the test to be run, but it takes an hour to physically clean that machine afterwards. Now, you can't spray that with deep chemicals. It has to be manually cleaned. But if you use a UV light robot, that can clean that much more quickly. So ultraviolet light robots, they use ultraviolet germicidal irradiation to break down or damage the DNA inside microbes. This prevents the microbes from replicating and therefore from spreading infection. So it's a very effective method, and it's a very quick method. If you think about a hospital room where a patient has been, when they're discharged, it can take several hours to sterilize and clean that room in the current pandemic. Whereas a UV robot reportedly could have that time from several hours. And if you think about the high occupancy rates that some countries are dealing with, this fast turnaround time to release a room essentially very quickly is critical. These robots can also operate in high traffic areas like hallways, where manual cleaning might be less effective because it's more difficult to keep on top of it. Now, you might be thinking, UV rays are dangerous to humans, and indeed they are, and so are chemicals that are sprayed out. So no different to the manufacturing environment where safety is very important. Human safety is also important in this case. And these mobile robots are equipped with sensors and artificial intelligence, or basically digital processing in order to detect when a human comes into that particular environment, and then they can stop what they're doing and the human moves on safely. Another area or another example is the area of material transport. So literally just moving things around, whether that's in a hospital, in a lab, in a logistics center. And this has already been an area of automation, but it's just growing, particularly during the COVID-19 pandemic. So this is, creating more efficiencies, but it's also reducing the human interaction. If you have something delivering samples or delivering laundry or whatever it might be in a hospital. What's also excellent about these mobile robots is, again, I talked about total cost of ownership earlier with collaborative robots. Similarly, a laboratory or a hospital that wants to take advantage of these types of robots, they don't want to have to spend money on special installations in their buildings to help these robots get around. And they don't have to, because they are intelligent or autonomous enough to be dropped into a new environment and be able to locate and move within that environment easily. And the final example that I have is picking and placing, or picking and sorting of items. So if you think of logistics and distribution warehouses and e-commerce, again, this is it has been an area of high growth, but as I said, there's an explosion of this at the moment as people don't go out to the shops. Many more people are buying online. So there's an even greater burden on the companies that run these distribution centres, and they're also potentially facing a missing workforce as well. So robots that can both transport the materials around, but also pick through, as I said, artificial intelligence can help them identify objects and pack those goods. This is really helping at the moment in the pandemic. And to be honest with you, there could be perpetual change here as consumer buying patterns change. Some people will probably go back to their old ways of going to the stores. Other people may stick with online shopping, or you'll have people that will continue to online shop for much more of their business. So there's likely to be perpetual change here. Now, prior to the COVID-19 pandemic, there was already an upsurge in the number of new startups and companies getting into developing collaborative robots or mobile robots, either the hardware or the software or the artificial intelligence. But as a result of this pandemic, and as we're seeing growth in some of the areas like the examples I just took you through, I'm now starting to see how, some of the traditional robotic OEM makers, the companies that make the large industrial robots, there's every chance that they will start to look to these new markets and think about developing new kinds of robots, different kinds of robots that they may not have made in the past, and maybe extending their robot product lines. So I have talked quite a bit about the challenges that are facing manufacturers or factory operators, for example. But what about the challenges that are facing the actual robot makers? So the companies that make these traditional robots or the collaborative robots or the automated guided vehicles and mobile robots. Well, there are many system design and technical challenges that they face, and some of these are common across these three different categories of robots. The first area would be power conversion. Power conversion, this is located in the motor control domain within the system. And power conversion is a key challenge in terms of reducing size, reducing making energy efficiency, for example, reducing weight, because if you have an effective power conversion subsystem, then you can reduce your EMI filters, so that reduces size and weight. And miniaturization is pushing, it's pushing robot makers to reduce the size of robots, to fit more of these into a factory and get more out of a given footprint. And what comes with miniaturization is you get very tight, small spaces that electronics and motors have to work within, and that presents thermal challenges. And those thermal challenges demand better power management solutions. Another common area is functional safety. Functional safety is, human safety is paramount, and I've mentioned that a couple of times already. But not just human safety, functional safety also feeds into the productivity and uptime of a facility, making sure that if you need to do repairs or maintenance, that these can be done without having to shut down the entire facility. So in a way that protects the operations, protects the uptime, while also protecting the human. And there are many safety, functional safety standards and legislation that robot makers have to adhere to, and that's a challenge for them also. In traditional industrial robots, multi-axis synchronization and high precision motion control are critical. If you think about something like the quality of your cell phone, for example, when it's being assembled, when all of those different components are being put together and it's being finished, or the quality of the welds that hold your car together, or the surface finish on something that's very smooth. All of this is done with traditional industrial robots, and things like precision motion, force sensing, pressure sensing, all of these are very important considerations, and these are challenges for robot makers. Collaborative robots, these robots, as I said, work alongside humans. Now, the reality is that the majority of actual instances of robots collaborating with a human on the same workpiece, they're actually not as great as the number of instances of cooperation between robots and humans. Cooperation is where they're working side by side and maybe passing the workpiece between them. So that's far more common. But so there are varying degrees of collaboration or cooperation, but nevertheless, human safety is paramount, and that's another common trait with challenges in traditional robots. And like I said earlier, these mobile robots that are roaming around logistics centers or hospitals or factories, again, it's human safety is critical here to ensure that they don't crash into human beings. Another design challenge is motion control within collaborative robots or cobots. Now, in traditional industrial robots, there's a very high level of precise motion control required. But in collaborative robots, you don't need such a high level of precision here. A medium resolution solution is what's required, as these robots work on different types of tasks than they do with traditional robots. They're also not operating at very high speed like traditional robots. But the challenge actually, it sounds like that might be easier for the robot makers, but the challenge actually is in finding a cost-effective medium resolution position feedback solution. So position feedback, which is what gives you the servo control in a motion control loop. Some robot builders will do this themselves. Others will buy an encoder from a specialist encoder maker. Now, in robotics, traditionally, very high precision and expensive position encoders are used. These might be optical encoders, for example, very high precision. Collaborative robot makers are looking for something that is cost-effective, that has the right kind of mechanicals for the space constraints they face, and also that is rugged and robust. And there is a likelihood here that magnetic encoder solutions rather than optical encoder solutions could come to the fore here because they may be more affordable and more rugged. For mobile robots, navigation and stabilization, because they're moving around, these are key challenges as well for them. So these are just some examples, a few examples of the challenges that robot makers are facing. So, and you may be wondering how ADI is helping in the face of these challenges. Well, we're seeing that robots are becoming increasingly connected, collaborative, increasingly productive, and increasingly flexible. And this demands advancements across many areas of technology, areas like sensing, precision measurement, safety, as I mentioned, navigation and stabilization, orientation, power and size efficiencies, machine reliability, communications, and even cybersecurity, for example. And these are all areas that ADI has solutions in. And if we look at the subsystems within a robot, some of the sub-elements of a robot, I can give you a few examples. So if we take the drive control or the inverter, so it could be an inverter. In the case of a mobile robot, it could be a servo drive then, which has position feedback in a collaborative robot or a traditional industrial robot. Here, very high precision current and voltage sensing within the motor control are key to getting very precise torque control. As I mentioned a few times already, multi-axis synchronization is key here, and both our data conversion and our communication solutions come to bear here. Position feedback or encoders that I mentioned earlier, this is another subsystem. And here Analog Devices has a whole range of solutions in simultaneous sampling, successive approximation, analog to digital converters, and also isolated transceivers that we can bring to bear on high precision and medium resolution encoder solutions, as we have magnetic sensing solutions available also. The area of connectivity within robots and around robots, wired connectivity, this could be anywhere from RS485 serial type interfaces to full Ethernet, and EtherCAT is actually quite popular in the architectures of robots. So Analog Devices has a wide portfolio of isolated and non-isolated transceivers with multiple different protocols. But we also have a new portfolio and a new brand called ADI Cronus. And ADI Cronus encompasses our industrial Ethernet solutions. We have industrial Ethernet platforms, industrial Ethernet switches, which are multi-protocol, and industrial Ethernet PHYs. And the PHYs are at 100 megabit and gigabit speeds. And these are all across multiple protocols, as I say, and they are also enabled for TSN. So they are compatible with legacy networks and also future-proofed for convergence in the factory floor. And these solutions, the things like the PHY and the switch, the actual timing capabilities in terms of latencies and power consumption, for example, this all feeds directly into the multi-axis synchronization that I spoke about earlier. So knowing exactly where an axis is when in real time. So real-time deterministic Ethernet is absolutely critical to precision motion control in multi-axis robotics. Functional safety is, as I've mentioned this several times, Analog Devices has, and our team, we have a 100% focused functional safety expert in the form of Tom Levy. Tom has a functional safety blog on our website, which you might enjoy looking at. Tom is an expert in all of the safety standards related to industrial machinery, robots, cobots, mobile robots, which some people call mobots. And Tom and our team help our customers make sense of these, follow the evolution of these standards, and help them to adhere to these standards and implement the required design topologies, for example, to realize the appropriate safety in their end design. Power and battery management is also critical. I've spoken about power management already. We have our ADI Power by Linear portfolio and brand, and here we have a huge range of power solutions that can be brought to bear. As I mentioned earlier, miniaturization is a key trend, so reducing size, weight, dealing with thermal efficiencies. But also battery management is critical for mobile robots. Between charges, they need circuitry to manage the state of that battery. And ADI has solutions that are suitable for multiple different types of battery chemistry, whether that's lithium ion, whether it's lead acid or nickel based. I spoke about grippers and end effectors as well. Smart grippers and smart end effectors, these extend the range of tasks that a collaborative robot or robot can achieve and work with. As I mentioned a few times, plug and play interfaces are critical, and we feed in here. And force and sensing. So, a gripper picking up something, you don't want to crush it. If you have a lead screw tightening application, for example, you don't want to over tighten that. So torque sensors or like strain gauge type sensors. These are used in the wrist of the robot. And analog devices have a wide portfolio of data conversion solutions that can are perfectly suited to these types of signal chains. And indeed, as I mentioned already, for the drive and inverter control, data conversion is key there for the current and voltage sensing, but so too is our magnetic isolation technology in the form of our iCoupler brand and our power conversion solutions, as we have both isolated and non-isolated gate drivers. Analog devices has a long history in bridging the physical and the digital worlds. We have a long heritage in semiconductor manufacturing and development, as you may be aware. So analog devices, we effectively create data, but creating the data is only the start. We are leaders in converting real-world phenomena into insights that can transform our customers' industries. We're the best at measuring analog signals. And when you combine this with processing, analytics, system-level knowledge, then these insights really become actionable for our customers. We have a huge breadth of technologies that we can bring to bear on industrial robotics and automation. And we do this through a system-level focus. We go beyond the component into the system-level problems. We can offer software solutions, artificial intelligence, functional safety, as I said earlier, expertise in that. We can offer algorithm development and in some cases even a module capability. So we have domain experts working in our teams that really have a system focus. And when you combine that system focus with our technology, we really become the partner of choice for our customers, helping them to get on board with a megatrend like Industry 4.0. So you can see that ADI enables safer, more productive facilities. We improve efficiencies, energy efficiencies of ourselves, of our customers, our customer's customer, and the world around us. And in closing, I'd just like to leave you with 4 key points. Firstly, I think companies that have already invested in automation and robotics during the current pandemic, I think they're seeing an acceleration on the payback period or the return on that investment, as we see robotics and automation come to the fore of helping in this current crisis. Secondly, the COVID-19 crisis has brought into sharp focus the potential to reorder the global supply chain to, create proximity or, shorten the distance between the supply and demand and bring manufacturing facilities closer to the area of consumption, as I mentioned earlier. Thirdly, robots are and will continue to support society. They will help with the recovery, as I spoke about earlier. I think that as we go through this pandemic and as we go through phases to come out of it, there will be new norms, as I mentioned earlier, in workplaces, new safety protocols that have to be implemented. So I think some of these, this environment will persist and robotics can help with that. And finally, I would just like to come back to those negative headlines. They really risk overshadowing the very real positive contribution that robots can bring to society, to workplaces, to job creation. And they also risk undermining discussions that should be happening about measures that need to be taken to enable countries, organizations, and individuals to reap the rewards of automation and robotics. Thank you for listening. I hope that you found this talk useful, and if nothing else, I hope that it might have given you a slightly brighter outlook.